is a kind of transverse wave that causes sensation to vision. If there is no light here, you won't see what I'm doing. And it's a transverse wave because the wave is perpendicular to the source vibration producing it. And we have sources of light. First, there are two types of sources of light. First one, we have the natural source of light. These are sources of light that are not made by man. Natural sources of light, they are not made by man. They are things we see and they cause sensation to vision, but yet they are not made by man. Example, the sunlight, the moon, the stars, they glow insects, they glow warm. All these are natural source of light and they are not made by man. My dear, do you know that human forehead is a source of light and is a natural source of light? We are coming to explain that. Now, the second one is artificial source of light. Artificial source of light. These are man-made sources of light. For example, the ambient lights, the bulb, your torchlight, all those ones, the road sign, they are man-made and they are artificial sources of light. From there we'll come down to types of light. Types of light. First, we have the first group which we call luminous types of light. Luminous type of light. And secondly, we'll have non-luminous type of light. We explain. Luminous type of light. This is a kind of light that produces light on its own without any external optical effect. It doesn't need any other light to produce light. It produces light on its own. Example, the sunlight, the ambient light, the torchlight. They are producing light on their own. There is no optical effect. There is no light giving them light then before they will give back. They are just producing it on their own. Those ones are called luminous type of light. Your glow insect is a luminous type of light. Now, but non-luminous type of light, this one has no ability to produce light on their own. Rather, they absorb light and emit. That means they need optical effect before they can produce light. Example, your road sign. When you look at the road sign, when you shine light on it, it reflects light back to you. That is the way it produces light. Remember initially I said human forehead is a source of light. And I know you may be wondering since then. Luminous type of light, human forehead is not there. Because human forehead cannot produce light on its own. But yet, non-luminous type of light, human forehead is an example. Because it can reflect light. If you are in a classroom watching this on Fusion, Petaled, Nigeria, look to the next person near the window. If it's on the right, look at the right hand side. You will notice that you see a white light shining there. It is reflecting light, and that is a non-luminous type of light. Already there I've told you what reflection is. Now we want to relate it to light. When we say reflection of light, no longer generally in wave, it simply means the ability of light to bounce back or bounce away when it encounters an obstacle. And there are two types of reflection. The first, we have what we call regular reflection. Regular reflection. This one is obtained from a smooth surface. Example, if I have something this way, which is a very smooth surface, and I send in rays of light to it, you will see that the rays of light will go this way. So, in regular reflection, we'll say that the entire rays of light are reflected in same direction because they had a contact with a smooth surface. While we have the second one, which we call irregular reflection. Irregular reflection. Remember, the first one is regular, the second one is what? Irregular reflection. Another name for irregular reflection is scattered reflection or diffused reflection. And from the name scattered, it simply means that the rays are incident on a rough surface. And since it's incident on a rough surface, the whole rays coming will be scattered in different directions. Maybe you see this one going this way, and that one coming that way, and this one going that way. Looking at this, they are not in the same direction like the first one, so we call it scattered reflection. That's another name for irregular reflection. So when it's on a smooth surface and moving in the same direction, we call it regular reflection. And when it's on a rough surface and scatters after reflection, we call it what? Scattered reflection or irregular reflection. From there, we'll enter laws of reflection. Listen carefully now because this part is very important. Laws of reflection. The first law of reflection states that the incident ray, which is this, a ray coming from your torch, a ray coming from your lens, the incident ray, the reflected ray, and the normal. My dear, listen to me very well. I did not say normal ray. No. I said what? The normal. The normal there is not a ray. It's just an imaginary line which you assume that creates 90% to the plane which you are working on. If this is a mirror, for example, there is a particular imaginary line you have there in your brain that creates 90 degrees to this particular mirror. It is called the normal. Why this is the incident ray coming down and this is what? The reflected ray. The first law says that the incident ray, the reflected ray, and the normal all lie on the same plane. Look at the plane here. So 1, 2, 3 all lie on the same plane. That is the first law. While the second law of reflection states that since this is the incident ray and this is the reflected ray, here will be assumed to be incident angle and here is what? Reflected angle. My dear, watch well. I did not give you the incident angle from the plane. I gave it to you from the normal. Many a times, JAMB will confuse you and they will put it at the normal. They will put something here at the plane and say calculate the reflected ray. And you use that thing they put up here to obey the second law. And it's a collapse. It's a total failure. Look at where your incident ray is and this is your reflected ray. And second law states that the incident ray must be equal to the reflected ray. That is the second law of reflection. That however you like, twist this thing, that your incident angle must be equal to the reflected angle. Remember the first law. First law says incident ray, reflected ray, normal, all lie on the same plane at the point of incident. While the second law states that at the same point of incident, that the angle of incident must be equal to the angle of reflection. We move over to refraction. Okay, on refraction of light, we'll say that is the ability in which light can change its direction when it's moving from one medium to another. At the boundary of two media, whenever light is moving, it changes direction. Example, practice this for me now. Go and take a bucket of water and drop a stick or a meter rule in it. You notice that the part inside the water seems bent. Why? Because of what? Refraction of light. And there are two laws governing refraction of light. The first one states that the incident ray, the refracted ray, because if I have this to be the normal and this is my plane, for example water now, and this part is air, and we have this. Refraction simply means that on getting to this point, normally we expect it to move straight, but it will not. There will be a little change. There will be a change in direction. Maybe you see it come this way. That is refraction. So the first law of refraction says that the incident ray I, the refracted ray R, and the normal N, this line. I didn't say the normal ray, the normal, that at the point of incident all lie on the same plane. Look at where they are lying. All of them are on this plane. 1, 2, 3. At this point of incident, all lie on this plane. That is the first law. While the second law says that if this is the angle of incident I, and here is the angle of refraction R, that the sine of angle of incident to the sine of angle of refraction is equal to a constant. That means the ratio of sine I to that of sine R is equal to a constant. And that means that if I push this thing this way, even if I decide to change this way, that this will also change in such a way that my answer here will remain the same. As I'm changing it, my answer here must remain the same. And we'll say that sine I over sine R is equal to a constant. And that is second law of refraction. First, I and R all lie on the same plane at the point of incident. Second, sine I over sine R is equal to K, where K is a constant of proportionality known as refractive index. I call it refractive index, which depends on the material. If it's water, our refractive index is about 1.333. If it's glass, like rectangular glass prism, the refractive index is about 1.5. But what you know, don't cram it. What you know is that sine I, the ratio of sine I to sine R must give you something that is a constant. From there, we come down to formation of images on plane mirror. If I have a plane mirror and I want to form an image on it, most especially those of you writing WAEC, learn this diagram now. That if this is my mirror and here is the principal axis, we have a particular object here that we want to take up the image in the mirror. The rule is that any ray that is parallel to the principal axis must be reflected the same way. But we have the extension into the mirror, and we have this one going this way, coming like this in reflection, while another one goes this way and come like this in reflection. These will extend, and these will also do what? Extend. At the point of their meeting inside is what we call our image. And this is the diagram of image formation on a plane mirror. If you look behind the mirror, I did not put any arrow showing you that there is no ray inside the mirror. It's just an extension of rays. The whole ray is here. And somewhere here, you notice that the image formation is on the eye of the observer. And this is the diagram. Take a proper look at it now. Here is my object. That's my image formation. And practice it. See whether you can do it now. So, from that point, we move over to what we call inclined mirrors. Inclined mirrors are two plane mirrors joined together at a certain angle of inclination. Maybe 60, maybe 30, maybe 20. But just assume it that I have two mirrors and I join them together at a certain angle. That is what we call inclined mirror. And moreover, whatever they ask for on inclined mirrors, many a times they may not ask you to define inclined mirrors, but they will surely ask. Call it UTME, GCE, WAEC. They will ask you to calculate the number of images formed on an inclined mirror. And that is what we are going to do now. In calculating number of images formed on inclined mirrors, we take over this formula which says that n is equal to 360 over theta minus 1. That means n is the number of images formed, 360 is a complete, and theta is the angle in question. If I example, we can ask, what is the number of images formed on an inclined mirror when the angle of inclination theta is equal to 90 degrees? We'll say that n is equal to 360 all over 9 minus 1. That means n is equal to 360 over 9 is 4 minus 1, n is equal to 3. That is it. That's the way to work on this, to calculate the number of images formed on an inclined mirror. And we work on that way. Again, they may say, okay, what is the number of images formed when the angle is 60? N is equal to 360 over 60 minus 1. That is, n is equal to 360 over 60 will have 6 minus 1, n is equal to 5. So any question given to you on inclined mirrors, this is the way you do it. Now if they ask you also to calculate the theta, what you do is just to make the theta the subject of the formula and move on with it. Whereby if you make theta the subject of the formula, you have something this way: theta equal to 360 over n minus 1. And you move on and calculate it. For example, if they say, what is the angle of inclination when the number of images formed is 5? What do we have? We'll say 5 is equal to 360 over theta minus 1. So this can cross over the equality sign, which is 1 and is minus. As it's crossing over, it becomes 6 here. We have 5 plus 1 equal to 360 over theta. That is 6 equal to 360 over theta. Making theta the subject of the formula, we'll have theta equal to 360 over 6. Theta is equal to 36 here, we have 6. That means theta is equal to 60 degrees. So this is the way to go about that when you are giving this one or you are giving that one. Moreover, the next thing I would like you to look into properly before any examination is rules governing image formation on curved mirrors. This time not plane mirrors, on curved mirrors. Already we've taken on plane mirrors, I've shown you that. This time I would like you to look at rules governing image formation on curved mirrors, and that you will also get from Fusion Petaloid Nigeria, precisely the physics clinic. We move over to sound, which is an example of longitudinal wave.